Hi, in this session we will discuss about changing the order of integration. So far we have discussed double integral over non-rectangular regions, and we have also discussed how ways to evaluate the two limits when it is integral f of xy, dx dy or dy dx. Both things also we have discussed so far. Now in this section we will have a type of problems like you will be given f of xy into dy dx, and the limits will be there, something will be there. Here we will be asked to change the order, means you have to change this f of xy dy dx to dx dy. Accordingly you know that the limits would also change, because in non-rectangular region simply you can't interchange the limits. You have to see the limits from the region by looking at the picture of the region. You have to write down the limits. So here you will be given a particular integral for like dx dy or dy dx, and you will have been asked to change the order and then evaluate. So we will do some problems related to that. So first of all, let us consider this problem, which is integral 0 to 2 and integral y by 2 to 1 e raised to x square dx dy. So changing the order means you need to evaluate this of the form e raised to x square dx square into dy dx. Now you have to try to supply the limits here by looking in the region, but the region is not mentioned here. You will draw the region accordingly according to the limits given in the given problem. Okay, so looking at the problem, you know that x is actually varying from y by 2 to 1, and your y is varying from 0 to 2. So we will draw the diagram accordingly. This is written from the limits of the given problem. So we will draw a graph accordingly. So how will the graph come? So if you draw the x and y axis, so this is your x axis, this is your y axis, this is your x axis. Okay, they say that your y is varying from 0 to 2, right? So we'll just plot it. So y is varying from the line 0, which is actually the x-axis, to y is equal to 2. So this is the line y is equal to 2. Okay, now your x is varying from y by 2. So y by 2 means actually it is 2x is equal to y. So in order to draw this point, 2 points are x is 0 0, and when x is x1 2. Okay, so basically if you have 0 0, this is 1, this is 2 here. So basically this will be the line 2x is equal to y. So 2x is equal to y2. Where is it going? Till x is equal to 1. So this is the line x is equal to, this is the line, if this is one sec. Okay, so this is the line 2x is equal to 1. Okay, so if you draw the line, this is the line 2x is equal to 1. So if you look at the region here, what is the region? The region here would be, you can see that y is varying from 0 to 2. It is lying between both these lines. Y is equal to 2 to y is equal to 0, and your x is starting from y by 2. X is moving horizontally like this. So starting from y by 2 to 1. So this is this triangular region given here, obtained by OAB, enclosed by OAB. This is the region here. Now we can write the limits here. So if you want dy dx, what will you do? First you will write the outermost limits first, which is that of x. What is the outermost limits of x? It is from 0 to 1. And look at the variation of y. Y is varying in the vertical direction. Y is starting from 0 to where is y going? Y is going till the line, y is going in this direction, so y is going till the line 2x. Okay, so now we evaluate this problem from this. Okay, so before we evaluate, you can see that we can't do the given problem directly. You can't do the given problem directly because you can't find the integral of e raised to x square. Okay, so directly you can't do the problem. So if you change the order, you can easily evaluate it, because if you see this problem, now we have changed the order. So how will you evaluate this? This will be integral 0 to 1. Okay, now e raised to x square is a constant with respect to y, so it will be like this, and you will get the integral as y in the limit 0 to 2x dx. So what is this? It is simply integral 0 to 1 e raised to x square into 2x dx. Now if you take x square is equal to u, your integral will simply become integral 0 to 1 e raised to u du. The value of this is actually e raised to 1 minus e raised to 0, that is actually e minus 1. Okay, so this is the integral. So you can see that some certain integrals which could not be evaluated directly can be easily computed by just changing the order. Okay, now this changing the order has made this problem a very easy problem. So we will do one more problem related to this. So let us see this problem. Integral 0 to 1 integral y to 1 sin x dx dy. So how will you do this? Again, you need to find integral sin x by x dy dx. Okay, so in order to supply the limits, you need to plot the region. So you can observe that y is varying from 0 to 1, and your x is varying from the line y to x is equal to 1. So if you plot the x and y axis, okay, so your y is varying from, just try to plot it, so your y is varying from 0 to 1, so y is varying from 0 to 1 here, and your x is varying from y axis, this x line x is equal to 1, this is the line y is equal to 1, this is the line y is equal to 0. Now x is varying from x is equal to y, so x is going from this line, so this is the line y is equal to x here. Okay, now can you identify the region? Your y is x, y, so y is varying from 0 to 1, so it is lying between these two line segments, and similarly, so these two regions, and your x is varying from y to 1, so basically this is the region. If you can see this shaded portion, OAB, triangular shaded portion, is the region. So how will you write the limits here? So you need dy dx, the full limits of x are actually 0 to 1. Now look at the variation of y varies in the horizontal vertical direction, so it's moving from the line 0 to y is equal to x, so this is the integral. Okay, now if you evaluate this, it will be simply sin x by x, integral 0 to 1 sin x by x is a constant with respect to y, so into y in the limit 0 to x dx, so that is actually integral 0 to 1 sin x by x into dx, which is nothing but integral 0 to 1 sin x dx, which is actually minus cos x in the limits 0 to 1, so we are getting minus cos 1 plus cos 0, that is actually 1 minus cos 1. So you can see that the seemingly difficult integral has been simplified by the method of changing the order. So I hope it is clear. So the procedure is, first you have to, if you are given dy dx, you need to convert it to dx dy, you have to write the limits. Now the limits are obtained by just plotting the diagram to get an idea. Once you plot the diagram, it is very easy to evaluate. Okay, thank you.